A matrix is a rectangular array of numbers. A rectangular array of numbers. A rectangular array of numbers enclosed with a pair of brackets. Enclosed with a pair of brackets. E.g. A equals to 2, 4, 3, 1, -2, 5, 6, 2, 1. So that is what we call a matrix. It's going to be enclosed with a pair of brackets. So we continue. Matrices are used in representing and mathematically manipulating target mass of data. Target mass of data. Matrices are useful in representing and mathematically manipulating larger mass of data. So let's look at the general structure of a matrix. General structure of a matrix. So you can have a matrix A equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. So you can have a matrix like that. That's the general structure of a matrix. So you write that general structure of a matrix. We are going to write that. So you start by writing NB, just write NB. We are going to look at that particular matrix, NB. Number one, a matrix is denoted using a capital letter, e.g. matrix A, this one. A matrix is denoted using a capital letter, e.g. matrix A. So the element A12, the element A12 appears in the row 1, column 2. Row 1 and column 2. The element of A21 appeared in row 2, column 1. Now it means that we start with the row, then column. We are together. We start with the row, then column. Okay, we continue. Matrix A has M rows and N column. Matrix A has M rows and N column, and is said to be an order of M times N, and is said to be an order of M times N. Now, in this case, This is the order of the matrix, whereby the first letter is going to be the row. The second one is going to be the column. So this is M times N order. Now, when you look at the other order, maybe you can write this one. B equals to 2, 3, 4, 1, negative 2, and 3. So if you are told what's the order of this particular matrix, the order of this matrix is going to be 2 by 3 matrix. But that's the order for the matrix. We are together. We count the row 1, 2, column 1, 2, 3. We start with row and then column. We are together. So you continue. Let's look at the types of matrices. Types of matrices. Types of matrices. The first one is known as vector matrix. Vector matrix. The first one is known as the vector matrix. Now, what's a vector matrix? What's a vector matrix? So you continue by saying a vector matrix is a matrix which has a single row or a single column. A matrix which has a single row or a single column. A single row or a single column. So the vector matrix is going to be, assuming this is A, 2, 3, 4. That's a vector matrix, or B equals to 3, 1, 4. This is known as a vector matrix. It has a single row or a single column. So this is single row. This is a single column. We are together. Now the second one, we have the square matrix. Square matrix. Square matrix. What's a square matrix? A square matrix is a matrix. A square matrix is a matrix which has the same number of rows and columns. Which has the same number of rows and columns. So when you find the matrix with the same number of rows and columns, that one we consider as a square matrix. As example, A equals to 2, 4, 1, 3. This is a square matrix which is known as 2 by 2 matrix. Maybe we have B equals to 3, 4, 5, 2, 1, negative 2, 4, 6, 0. This is known as a square matrix of 3 by 3 matrix. Get together? That is known as the square matrix. Now, the next one, we are going to look at, it's known as the null matrix. Null matrix. Null matrix. What's a null matrix? It's a matrix. This is a matrix. A null matrix is a matrix whose all elements are equal to 0. Whose all elements are equal to 0. Example, we can talk about A equals to 0, 0, 0, 0. B may be equals to 0, 0, 0, 0, 0, 0, 0, 0, 0. That is known as the null matrix. Null matrix. Now, the next one, we are going to look at the diagonal matrix. Diagonal matrix. Diagonal matrix. Now, when we talk about a diagonal matrix, we talk about the matrix. It is a matrix So you just, sorry, just going to say this is a square matrix. This is a square matrix whose every element is 0. Whose every element is 0, apart from at least one in the primary or the leading diagonal. Apart from at least one in the primary or the leading diagonal. Now we look at the matrix, like we talk about A equals to maybe 0, 0, 0, 2. That's known as the diagonal matrix. This particular diagonal, this is what we call the leading diagonal. This particular diagonal is the leading diagonal, or we call it the primary diagonal. So another one, we go to the scalars matrix. We look at what's known as scalars matrix. What's a scalar matrix? So you continue by saying a scalar matrix. This is a diagonal matrix. This is a diagonal matrix whose leading diagonals elements, whose leading diagonal elements. This is a diagonal matrix whose leading diagonal elements equals to one another, equals to one another. Together. So we are talking about, for example, we talk about A equals to 2, 0, 0, 0, 2, 0, 0, 0, 2. So the leading diagonal there is equals to one another. The next one, we look at the identity matrix. Identity matrix. It is a matrix whose every element, matrix whose every element in the leading diagonal is equals to 1. Is equals to 1. So we are talking about the leading diagonal, this one. So we can say B equals to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is identity matrix. That is known as the identity matrix. Now let's look at the next one. It's known as the submatrix. 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 Submatrix is a matrix obtained from another larger matrix. It's a matrix obtained from another larger matrix by deleting or omitting. By deleting or omitting one or more rows and columns. One or more rows and columns. Then we look at the next one, transpose. The transpose a matrix. That's transposition. Transpose a matrix. Transpose a matrix. Now, when you talk about matrix, when you talk about the transpose a matrix, We are talking about the matrix whereby you are going to interchange the column and the row. So you continue by saying, this is obtained by interchanging rows and column. This is obtained by interchanging rows and column. For instance, you can say A equals to 3, 4, 2, 1. No, now, if you have to get the transpose of A, you're going to say that you interchange this one to be the column. So it's 3, 4, 2, 1. That's the transpose. Another one, we have what's known as symmetric matrix. Symmetric matrix. Symmetric matrix. It is a matrix which is self-transposed. Matrix which is self-transposed. Now I want to see if I can try that one first. Let me try. 2, 3, 2. So okay, 3, 2. Yeah, this one. Now, if you transpose this one, what are you going to get? A transpose equals going to be 3. Is it 3? 3, 2, and then 2, 3, which is the same. Because now that is what we call a symmetric matrix. Okay, we are going to look at what is known as matrix operation. Matrix operation. Let's look at the matrix operation. Now, these are the ways of obtaining 2 or more matrices. The way of obtaining 2 or more matrices. 2 or more matrices. 2 or more matrices. To obtain other matrix of interest. To obtain other matrix of interest. Now, we continue by saying this gives rise to a matrix algebra. This gives rise to a matrix algebra. So the common matrix operations are: 1, we have addition. 2, we have subtraction. 3, we have multiplication. 4, we have the inversion. Those are common matrix operation. So we start with the addition. So we are going to start with the addition. Let's start with the addition. Now continue. The matrices are added together. The matrices are added together. These are only possible if the two or more matrices are of the same order. The two or more matrices are of the same order. Now let's try to look at example. Assuming we have matrix A equals to 3, 4, 5, 6, and then B equals to -1, 3, -7, 1. So we are told to add matrix A plus matrix B. Now, first we must look at their order. This is going to be 2 by 2 matrix. This one also is 2 by 2 matrix. Now, they have the same order. This simply means that we can add the two matrices here together. So we are going to say that A plus B equals to what? C. That's going to be 3, 4, 5, 6 plus -1, 3, -7, 1 will give us what? So we take this one, we add to this. We take this, we add to this. So this plus this, 2 here together. This plus this, 7. We take 5, we add to this, -2. We take 6, we add to 1, 7. Hiyo tuko sawa hapo? Hiyo tuko sawa? Now let's just continue. We go to subtraction. The second operation, and then I want to do another example. Subtraction. So we continue by saying we are looking at the subtraction. When two or more matrices are subtracted, and this is only possible when the matrices are of the same order. This is only possible when the matrices are of the same order. Now let's look at this matrix. A equals to 3, 4, 5, 6, 7, 8, 4, 2, 1. And B equals to -1, 5, -7, 3, 4, 2, then 1, 7, 0. Now this particular matrix is going to be 3 by 3. This is going to be 3 by 3. Now, so if you are told to get, you subtract the two matrices, we can say A minus what? B. So that's going to be that's going to be 3, 4, 5, 6, 7, 8, 4, 2, 1, minus -1, 5, -7, 3, 4, 2, 1, 7, 0. It's going to give us, we take this minus this, this minus this, this minus this. So the first one, negative what? The first is going to be 4. Right together. 9. 12. 3. 5, 7, 6. 3. That is going to be negative 5 there. So that is matrix addition.
Yeah.
This one and this.
One side.
This one.
The second one. Yeah. Cut.
You. 4.
4.
4.
And then you get 5.
Okay, do for me this one. Add matrix A plus matrix B. So matrix A will be equals to 3, 4, 5, 6, 7, 8. then B equals to 3, 1, 2, 7, 3, 0. Add A plus B. You add the two. Add A plus B.